Hello everyone, welcome to my session Beyond Ingress, Mastering the Kubernetes Gateway API. The plan today is that I give you an overview of the Gateway API and also what the difference between Gateway API and Ingress is. So first off, we're going to start with just a very quick introduction how we can expose our Kubernetes pods to the outside. Then I give you an overview of the Gateway API and all its components. Then we're going to take a look at how we can do the routing with the Gateway API. Then we have the comparison with the Ingress. Then I'm going to quickly introduce a couple Gateway API controller, for example, like Nginx or Traffic, as well as an Azure specific one. And most of the time we're going to spend at the demo, where I'll show you how to set up an entire environment. This means we are going to create a Kubernetes cluster using Azure. Then we deploy the Gateway API, and then we have a test application which we can access. If you're interested in the slides or the demo, you can scan this QR code and you will find everything on my GitHub. Before I get started, a couple sentences about myself. My name is Wolfgang Ofner. I'm a freelance cloud architect based in Toronto, Canada, and I focus on Azure, lately especially on security and governance, as well as Kubernetes and DevOps. If you're interested in these topics, you will find a lot of videos on my YouTube channel. And if you have any questions, feel free to message me on LinkedIn. With this out of the way, let's take a look at how we can expose our pods to the outside. So the easiest way is to have a service of the type load balancer. If you use a cloud Kubernetes solution, for example, Azure Kubernetes Service, then the cloud provider will give you a public IP address. This means you can access your service and therefore the application over the internet. Another option would be to have an Ingress. This means you have an Ingress controller like Traffic or Nginx, and this is the single entry point to your cluster. Therefore, only the Ingress has a public IP address and then routes the traffic to the right service and therefore also to the application. Then the newer approach is the Gateway API. It is fairly similar to the Ingress. This means we have a Gateway API controller, which again can be Nginx or Traffic, and it works very similar to the Ingress. This means you also have one public IP address on the Gateway controller, and then you can route the traffic to your applications. There are also more features with Ingress and Gateway API, but we'll talk about this in a couple minutes. The first thing to remember is that the Gateway API is kind of Ingress version 2. So it took a lot of the problems we had with Ingress and improved upon them. But also more on this later. So first now let's take a look at the overall Ingress and Gateway API features. So the most important feature probably is that we have one entry point to your cluster. And this makes it easier to have full control over what is going on in our cluster and how we can access it. For example, with our DNS entries, we can just have one IP address and then we point our domains to this one IP address. Having this one entry point also allows us to have better routing because we only have one location inside the cluster where we have to configure the routing. We have different options. We can route based on the path, on the host name, on query parameter, but everything can be configured in the Ingress or the Gateway API. Additionally, with both solutions, Ingress and Gateway API, we can automatically create TLS certificates using the cert manager. That's just an additional tool we can install, and then we can link the cert manager to either the Ingress or the Gateway API. This will allow us to create automatically TLS certificates for HTTPS connections, and the cert manager will also update the certificates before they expire. I'm not going to show you the cert manager today, but if you're interested, I have another session at this conference where I tell you everything about the cert manager and I also show you how to set it up. Lastly, the Ingress and Gateway API both can do TLS termination. This means we have a HTTPS connection up to our controller, either Ingress or Gateway, then the TLS termination, and then from there to our application, we have a normal HTTP connection on port 80. So now let's take a look at the Ingress. As I said, we have different Ingress controller. The most popular ones are probably Traffic and Nginx. Especially Nginx was a lot on Reddit and social media lately, because in March, the most popular Nginx open source implementation will be end of life, and therefore many people and teams were looking for an alternative. If you're using Azure, you also have the Application Gateway Ingress controller. This means that's an Azure service that will run outside of your cluster, but will process all the requests and then forward it to your applications. This means you don't need the resources inside the cluster, and you can also have some additional features, for example, a web application firewall, the WAF, and this will help you to keep your cluster secure. I said before, we have Gateway API as kind of version 2 because Ingress has a couple downsides or problems. Let's call them downsides. So the first disadvantage of the Ingress is that the Ingress controller has a lot of control over everything, but especially how the traffic is routed. So the entire configuration for the routing is inside your Ingress controller. And probably the biggest problem is that Ingress uses annotations for all the functionality. But the problem with this approach is that annotations are linked to a vendor. For example, if I use Nginx as my Ingress controller, then I have to use the Nginx annotation. So it's not easy to switch over to, for example, traffic, because I have to change a lot of my annotations, which means I have to take a look at my applications, my services, and so on. If you have a big cluster, this can be quite a vendor login because it would be too much to switch. And the last downside I would say is that we don't have any cross namespace support for TLS certificates. This means all the TLS certificates have to be in the same namespace as our application. Therefore, we can't have a separation of concern because TLS certificate should be more on the operation side and the application should be more on the development side. But with the Ingress, the developers have to take care of both. I actually just remembered that I have a second slide with downsides of Ingress, but I don't want to give you the impression that Ingress is terrible. It's just an older implementation, and over the years we learned how we could improve on it. Therefore, from the perspective of 2026, we have quite some downsides. An additional downside is that we don't have any traffic policies available for Ingress. This means we don't have much control over how our traffic flows. Then I kind of mentioned before with the TLS secrets, but overall Ingress is designed for one namespace. This means we don't have modularity, everything is in one location and it has to be in one namespace. Therefore, we don't have separation of concerns. We have the Ingress object, and the Ingress object contains everything. For example, what are the routes we have, what's the hostname we have, our TLS certificates, everything is inside this one Ingress file. Therefore, in 2023, the Gateway API was announced to solve all these downsides and improve upon it. And by now, the Gateway API is, I think, in a great place. And if you start from scratch, I would go with the Gateway API. And the rest of the session today is to focus on the Gateway API, and I want to show you how we can use it. One major advantage of the Gateway API is that it's modular and it's split up into different parts. This means we have one file for our routing information, we have one file for the gateway, we have one file for the gateway class. And this makes it way easier to manage it, and we can also have separation of concerns. So we can give all the files to the operations team if you want, but we can also have some for the developers. As I just mentioned, we have a gateway class. This tells our gateway what gateway controller it uses. That's very similar to the Ingress class. So for example, we're going to see that we have a gateway. So this is basically the brain or the main part of our Gateway API. And we tell it what controller it should use to process requests. This could be again Nginx or traffic. And with this, the gateway knows which controller to use. We don't have any annotation. We just have the standards, and this makes it also very easy to change the controller if you want to. So as I just said, the gateway class depends on the gateway controller. In my demo later, I'm going to use Envoy as my gateway API, and so we'll see that the gateway class references the Envoy controller. As a sneak peek, we can take a look at the gateway class. So this Kubernetes resource or object that lives in no namespace, so it's a global object. Then we provide a name for it. In this case, I use the name Envoy because I'm using the Envoy controller, so it makes it easy for me to know what's going on behind the scenes. And then we have the reference to the controller. This is something you find in the documentation of your controller. In this case, it's from Envoy, and you just tell the gateway class which controller you're using. Here we have an overview how a request is processed with the gateway API. So if I type into my browser, for example, https example.com, then my DNS points to the public IP address of my gateway controller. Therefore, my request lands at the gateway. Then the gateway has the gateway class. This means it knows which controller to use to process my request. And it also has a link or reference to the TLS certificate. This means it can check my connection, and it can also terminate my TLS configuration. This is basically the same as the Ingress would do, but what's new is the route object, which links the gateway to the service. This means in this route, I can configure if I have a request to example.com, send the request to my service, and therefore the request will end up at the pods and the application will be served to me. So if you now take a look at the gateway, as we have seen before, it contains all our listeners. This means I have one spot where I can configure the paths, the ports and the URLs I'm listening to. Additionally, if I'm using HTTPS, it has a link to the TLS certificate. This can be in the same namespace or a different namespace. What's great about the gateway is that it is deployed to one namespace. This means you can have multiple gateways in different namespaces if you want to. This would make sense if you have maybe a critical application which you want to separate from all the other applications, or you have test and prod environments in the same cluster and you want to use different gateways for this. I usually use only one gateway because it's easier to manage, but you're free to do whatever you want and whatever fits your workload or your requirements best. Then I think I said it before, the gateway has a link to the gateway class, and therefore the gateway knows which controller to use to process the request. So if you take a look at the gateway configuration, we can see here we have the Kubernetes object of kind gateway. Then we provide some basic information like the name of the gateway and in what namespace we want to deploy it. Then we can also see we have one annotation, and here we provide the name of the cluster issuer. So that's part of the cert manager. And with this annotation, our cert manager will automatically create the TLS certificates for us. I'm not going to into detail for the cert manager today. And as I said before, I have a different session on the cert manager today. So it's just so you know, everything can be inside the gateway. After this, we have also the link to our gateway class. And what we can see here is it is the same name as the gateway class I have created before. And with this, I have the link from the gateway to my controller, and therefore my gateway knows to use Envoy to process the request. If I want to change the gateway API controller, for example, from Envoy to Nginx, then I can just change this gateway class, or I could just provide a new gateway class with the same name, then I wouldn't even have to update my gateway. So there's no annotation, no vendor login, so everything can be changed very easily. Lastly, we see here we have some listeners. Here we see the first one, that's an HTTP listener. This means it's listening on port 80 for the protocol HTTP, and it allows routes from all namespaces. This means my gateway will be deployed in the namespace gateway NS, and it allows all routes from any namespace. So if I have my demo application in the namespace demo app, then this demo app can create a route connecting to the gateway. But I could also lock this down that I only accept routes from my own namespace. Here again, it depends on your requirement. For me, I want to keep it as easy as possible, especially for the demo if you want to follow along, so I allow all routes. Then if we scroll down a little bit, we see a second listener. This time we are listening for the protocol HTTPS on port 443. Then we also have a hosting configured. This means if I type into my browser demo.programwithwolfgang.com, then this DNS entry points to my public IP address of the gateway controller. And then my gateway API will use this listener to process my request. Since I'm using HTTPS, I also need a TLS secret, which will contain the TLS certificate. And here I provide the name of the secret. I did not provide any namespace. This means the secret will be created in the same namespace as the gateway. But if I want to, I could create it in a different namespace. The only thing I have to take care of is I have to create a so-called reference grant, because by default, I'm only allowed to access the secret from within the same namespace. Since the gateway is in a different namespace, I have to create this reference grant to give my gateway access to the secret. Therefore, I use the same namespace for now to again keep it as simple as possible. So with this, now let's take a look how we can process our requests and how we can route the different applications based on various options. So first, as I said, we have the listener, and the listener is listening on different ports, like we have seen port 80 and 443, but it's also using different protocols. So we have seen we can use HTTP and HTTPS, that's probably the most common one, but we can also use TLS, TCP and UDP. This means we are very flexible in how we can listen for our requests and then later on how to process them. Then with the routing, I said we have our own routing objects, and there we can configure how we can handle our requests. So the first thing I want to take a look at is so-called weighted load balancing. The more common name probably is traffic splitting, and this allows me to split my requests to different backends. For example, I can say I want to send 10% of my requests to backend A or service A and 90% to service B. This allows me to do, for example, A/B testing, but it also allows me to do canary deployments. With canary deployments, I want to limit the blast radius of my new version if something goes wrong. So I can deploy my new version and then I send maybe 1% of my requests to the new version. Then I monitor it, and if everything is fine, I increase the percentage to maybe 3 or 5%. If that's good again, I can increase it to 10, 20% and so on until I'm at 100%, and then I can delete the old version. If something goes wrong, only a very limited amount of users will be impacted, and I can also easily switch back to the old version. What's great about these routes is it's using standards, so I don't have any annotations, and my routes don't even know what controller I'm using. So if I switch now from Nginx to Traffic or any other controller, I don't have to change anything because my routes are using standards and no vendor locked in annotations. For the routes, we can use the same protocols as before. So we have HTTPS and HTTP. Again, also TCP and UDP, but here we also have gRPC and TLS. This means we are also here very flexible and we can handle, for example, HTTP and gRPC requests differently. Now let's take a look at our routing object. Here you can see it's of type HTTPRoute. This means we are handling HTTP traffic. So you can also have, for example, a TLS route or a gRPC route, but to keep it simple, I'm going to use HTTP only. Then for the HTTP route, we have to provide a reference to the parent. The parent is always the gateway. And here I provide the name of the gateway and in what namespace it is deployed. Therefore, I have the link from my application to the gateway. And this will allow me to forward the request from the gateway to my service. I also have a hosting configured. This means if I enter in the browser demo.programwithwolfgang.com, then this route will process my request. On the bottom, we can see the rules, And here the most basic rule is send everything to the configured backend. In this case, I have a service, a Kubernetes service with the name traffic, and I send the request on port 80. Then the service sends it to my pods and I will get my application. For the routing itself, we just saw I send everything, but we can have different options how we can route. For example, I can route based on the path. This could be, for example, my URL/admin goes to a different backend than all the other requests. I can also route based on my header. The most common usage for this would be the user agent. For example, if I'm on a mobile device, I send it to a different service than if I'm on desktop. And so I can serve my clients better with specialized versions of the application. I can route based on the query, so I can read the query parameter, and I can also route based on the HTTP method. This means if I have a post, I can send it to a different service than my GET request. This will allow me also to separate the operations and help me with keeping my application stable. Lastly, I can also redirect requests. This is great if I have, let's say I have an online shop and after a couple of years I redesign my shop and my URLs change. But since my old URLs are still out there, I don't want them to produce 404 errors, so I can redirect the requests from the old one to the new one. Another example would be I can redirect from HTTP to HTTPS so that my clients always use HTTPS. Now let's take a look at the traffic splitting. So here again, we see again we have the host name with my URL, and in the backend references, I have two backends this time. So I have the application 1 and the application 2. Both are listening on port 80, but with the weight attribute, I can send what percentage do I want to send to application 1 and 2. Here you can see I have 20% to application 1 and I have 80% to application 2. So if I send 10 requests, on average, 2 requests will go to application 1 and 8 to application 2. What's important about the weight is it's not a percentage or anything. These two numbers are related. So if I have 20/80, it is exactly the same as 2 and 8 or 200 and 800. My recommendation would be to stay below 100 because that's the easiest to manage and to understand. Next up, we can also route based on our path. And here we can have different types. So for example, here I'm using the type path prefix. So if I have my URL/my/path, and no matter what's behind this, then I will do an URL rewrite. In this case, I replace the full path to /replaced. So for example, if I enter my URL/my/path/abc, then I will replace it to my URL/replaced. And if this route matches, then I send it to my service with the name app1. On the bottom, we can see here I also have a default service or a catch-all. So if none of the routes matches, then I send it to app2. This is something important because if you don't have the app2 here and a user has, for example, a typo and writes my/path without the H, then this rule won't match, but then there's no backend to send it to. And with this, I always send it to the backend number 2, and I can at least show an error message to my clients. This can be quite abstract when you see it the first time, especially when it's only on a couple of slides, but I've an extensive demo prepared and we're going to take a look at this in a couple minutes, and then I hope it makes more sense than right now. But before I do this, let's take a quick look at the Gateway API and the difference to the Ingress. And also my opinion. I said before, Ingress was, especially on Reddit, a lot talked about because Nginx is becoming end of life in March 2026, and people were like jumping on Ingress is dead, we have to switch to Gateway API. But my opinion is the Gateway API might not replace Ingress. The reason for that is Ingress is very easy to manage, especially if you have a small team. So I said before, everything is inside this Ingress controller. If you have a small team, the Ingress file is quite small and easy to manage. If you have hundreds of developers, then obviously it can get really big, really complicated. So Gateway API might be better for you. I also think if you're using the Ingress right now and don't have any problems, there's no reason to switch to the Gateway API. Yeah, it's the new shiny thing, but if everything works for you, never change a running system so you don't have to migrate. I think the Gateway API is also great if you have different teams. So if you have a dedicated infrastructure team, dedicated software teams, then you can have separation of concerns, and that's very easy with the Gateway API. So this might be a reason to use it. Personally, for new clusters, I'm always going to go with the Gateway API because I think it's quite easy to set up, quite easy to understand, and also to extend. But if I have to work with an Ingress controller, I'm also fine with it. So now let's take a couple looks at Gateway controller we have available. And if you used Ingress before, you will know all of them. So we have Nginx. This one is called Nginx Gateway Fabric. Then we have Traffic. We also have Ingress there. We have Envoy Gateway. That's the one I'm using for my demo today. It's personally my favorite because I think the documentation is the best. My second best would be Nginx. And Traffic, I had some problems, but it works as well. And also, if you're using Azure, we have the Azure Application Gateway for containers. And this provides additional features and it will run outside of your cluster. This means you can have, again, different teams manage it, and you don't need any resources inside the cluster. So let's take a look at the Application Gateway for containers, and then we start with our demo. The Application Gateway for containers is kind of a new service, and it was really complicated to set up because you need a lot of resources and permissions. But since February 2026, we have an add-on for AKS, and this will set up the Application Gateway for containers. So we barely have to do anything. The add-on is in preview right now. I tried it. Sometimes it doesn't work when you deploy it, so you have to redeploy it. But besides this, I didn't have any problems with it. What's great about the Application Gateway for containers is that we have additional features which we can't have with an in-cluster gateway controller. For example, we can have advanced health checks. So we can integrate it with Azure or with Prometheus, Grafana, all the tools we have, and we can have a combination of health checks, and we can also better monitor our applications. Then one of the biggest advantage probably is the WAF support. So the Web Application Firewall, we can easily link it to a gateway, but there we can say we can have firewall rules on the entire gateway or on specific listeners or even paths. So you can very granularly set the additional features or security features we want to have. I already mentioned it, but with monitoring, everything can be tied into Azure so we can have a better monitoring experience. And since it's running outside of the cluster, we can have auto-scaling and high availability, and everything is managed by Azure. So I don't have to take care of this. Here we can have an overview. So as I said, it's more complicated than an in-cluster controller. So my recommendation is if you want to take a look at the Gateway API, use an in-cluster controller. And if you have the requirements, then take a look at the Application Gateway for containers. But the way it works is inside our Kubernetes cluster, we install this ALB controller. ALB stands for Application Load Balancer. And this controller then creates the Application Gateway for containers for us. So we don't even directly create the Application Gateway. And in the past, we had to set up this ALB controller by ourselves. And now the AKS extension can do this for us. If you're interested in this setup, I have an extensive playlist on YouTube where I explain all the steps. And also the documentation from Microsoft is quite good. But for now, I would say that's plenty of theory. Now let's switch over to the terminal and let's get started with our demo to understand the Gateway API better. All right, here in the terminal, let's define a couple variables first. So this is going to be the information about our AKS cluster, like the name, the location, and the resource group. Then some information about our gateway, again, namespace name and the class name we're using, and then some information about the demo app. So the namespace, the 2 demo apps we're going to deploy, and my URL. With this, I'm going to create a new resource group. Then I'm going to deploy everything inside this resource group. This means after the demo, I can just delete the resource group and everything will be gone. Then I'm going to deploy a new AKS cluster. I just provide the most basic configuration, like the name and the resource group, and that's good enough for today. I said it before, but if you want to follow the demo, you will find everything on my GitHub repo. If you scan the QR code from the beginning or at the end of this video, and everything will be there so you can easily follow along. The deployment of the AKS cluster will take around 5 minutes, so I'm stopping the video and will continue once the cluster has been created. The cluster has been created, now I can download the credentials and so I can access it. What's important is that you don't need an AKS cluster. You can use any other cloud provider or even have it locally. It does not matter at all. But with this, now let's get started with the deployment for the Gateway API. So first, I'm going to deploy my Envoy Gateway. I'm using Helm for this. As you can see, I provide the version number. So as of recording, that's the newest version. Then I tell it in what namespace I want to deploy it. I create the namespace. And then I set the replicas to 3. This will allow me to have a high availability, so in case if one pod dies or crashes, I still have two pods left to process my requests. You can find all the information in the documentation. So if you use Envoy, Traffic or Nginx, they usually have quite good documentation. And I'm just using Envoy because I think it's the easiest one and I like the documentation the best. But all 3 are quite good. This should only take a couple seconds to download the Helm chart and then apply it. And here you can see it's already applied and we have our gateway controller now running. Next up, we need a gateway and a gateway class. So some gateway controller provide this out of the box, and with some you have to create it yourself. You can easily check this by using kubectl get gateway. And with the -A, we check all namespaces. And here you can see we don't have a gateway. We can do the same for gateway class. But since gateway class is a global object, it's not in one namespace. Therefore, we don't need any additional parameter. But here you can also see it's not found. This means we have to create it ourselves. So if we follow the demo, I have everything as a code. So I think it's easy to understand. Usually I would have it in different files, but just for the sake of the demo, I have everything here in code. And here you can see I'm creating my gateway class. So it's the type gateway class. I provide a name, and down here we have the link to my controller. Then I'm going to save this in the variable and apply the variable. So that's done. Now I can create my gateway. So I'm going to again paste the code. So here you can see it's type gateway. We provide the name and the namespace. Then I also have here the reference to the cluster issuer. We don't need this today because I'm not using the cert manager. I just left it in there so you can see in case you want to try it yourself. Then here we have the name to the gateway class. That's the one we just created. And down here we have the HTTP listener. This means we are listening on port 80 with my own URL. So this is demo.programmingwithwolfgang.com. Then we're going to save this in the variable and apply the variable. Then it takes usually a couple seconds until everything is applied. And since I'm using Azure, I will also get a public IP address that will be assigned to the gateway. To be more specific, the public IP address is assigned to the load balancer service of my gateway controller, but I will see it in the gateway. And to check this, I can do a kubectl get gateway and provide the namespace where we have just deployed it. And here you can see the gateway class. Then we have here the public IP address. That's the one I'm going to use to update my DNS record. And what's also very important is this program is set to true. So if you have something wrong in your configuration, then this might stay false. Usually it takes a couple seconds to switch from false to true. But if you waited a couple minutes and it's still false, then you have to take a look at your configuration. And the way to do this is with a kubectl describe. Then you provide a kubectl describe gateway. Then you provide the name of the gateway, which I just saw that I have a variable for this. So that's the gateway name. And the namespace where you have deployed the gateway. And here you can see everything that we have configured in the gateway and also what happened behind the scenes. So for example, here I can see the listener has been successfully translated. So for example, if I have an HTTPS listener and no cert matcher, it will tell me it's invalid because it doesn't have a TLS secret. But since I'm only using HTTP, everything is fine. So if we scroll up a bit, we can see here all the events. Then I can see here the address has been assigned. So that's the public IP address. If I scroll a bit further up, I can see here the public IP address. I can see here my gateway class, and I can also see here my listener. Since I'm using only one listener, it's very easy to see everything. But if you have more and more applications, it can get more and more complicated. But for now, that's great. And if you take a quick look at the gateway class we've created before, we can also see here that the accepted state is true. If you have here a problem, maybe a typo or we reference a controller that doesn't exist, then it might also be false, and this will help you to identify where the problem is. So now let's query again the public IP address. So that's this one. I'm going to copy this, and now let's switch over to the Azure portal and update my DNS record there. Here in the Azure portal, I already have the DNS records for my demo URL, but I've used it in the past with a different IP address, so I have to update this one now. As you can see, I have two entries. One is just a demo and the other one is a wildcard. And for today, we only need the demo one. If you're interested in the cert matcher, then we're also going to use the wildcard one. But that's again another session. So this is now saved. Now let's switch back to the terminal and let's deploy our demo application to test the access. Back in the terminal, I'm going to just paste my demo application, and don't worry if it looks very complicated. It's very simple and we don't have to care about it at all. It's just a simple application that receives a request on port 80 and then gives us some basic information. But if you want to follow the demo along, you have everything in here. So you can see we're going to create a new namespace. Then we have a deployment. Inside this deployment, I configure one replica, and I'm using the traffic who am I image. That's a small image that gives me some basic information of the application where it's running at, for example, what the host name is or what the pod name is. And this will help me to identify that I accessed the right application. On the bottom, we have one service. And what's important about this service, it's of type cluster IP, because I want to access my application only through the Gateway API. Therefore, my service shouldn't be accessible from outside the cluster. Let's save this in the variable and apply the variable. So now I've created the namespace, the service, and the application. And while this is being deployed, I do the same for a second application. So this is identically the same. So I even have here the namespace just in case if you want to use only one. The namespace already exists, so it's not going to do anything here. Then again, I have a deployment, but what I change is just the name of the application. I use again the same image. And for the service, also the same cluster IP type. Then we're going to apply this one. So also here it says the namespace is unchanged because it already existed, but it has deployed the application now. And if you do a kubectl get all, then we can see here we have our two services of cluster IP, and we have two pods running. One is called demo1 and the other one is called demo2. Actually, that's the deployments, the pods are here, but the name is the same except it has a different number at the end. So now we have our gateway and we have our application. Now we just need a link between these two, and we do this with an HTTP route. With the HTTP route, we tell the gateway where it should send the requests. So let me again paste my HTTP route. So here you can see it's of type HTTP route. It is in the same namespace as my demo application. This means it's independent of my gateway. Then I have a reference to the gateway. So I provide the name and the namespace of the gateway. I provide the host name. This means the URL I just configured, the demo.programmingwolfgang.com. And I send all the requests to the service with the name of the app1. So I'm going to apply this now. Then usually I wait a couple seconds just to make sure that everything has been applied. And after this, we can just do a simple curl. And if we scroll up a little bit, we can see here the host name, that's the pod name, is demo1. We can also see here we have HTTP 200, so everything is okay. And we can see here the host, that's the URL we called. So this proves we called the URL demo.programmingwolfgang.com. The DNS record for this URL points to the public IP address of the gateway. And then the gateway has a link through the HTTP route to my service of the application demo1. This service forwards the request to the pod and I get this response here. So this proves we were able to access our application through the Gateway API. Now that we have this basic setup, let's take a look how we can do some different routing options. So let me update our HTTP route. So on top, everything stays the same. It's again of type HTTP route. I provide the same name and namespace. I have the same reference to the Gateway API and also the same host name. What has changed is now these rules. So I have here two different rules. So first the path prefix with /routing, and then the path has to be exact/exact. So if one of these rules applies, then I will send my request to the service of the demo app1. If none of these rules fit, then I send all the other requests to the service of the demo app2. So what's important here with the path prefix is, as long as my path starts with /routing, it doesn't matter what comes afterwards. So it could be /routing/abc, then this rule would match. With the exact one, it has to be exact. So if it's /exact, it works. But if it's /exact/abc, it's not going to work because it's not a match. So let's create this variable and apply it. So then let's wait a couple seconds and then we can see what happens. So first, let's send another curl just with the demo URL. So in this case, none of the paths of the rules should match. And I can see I reached demo2. But now if I send a rule that matches, for example, the one with exact, I can see I reached demo1. So now I proved that I can route the request based on the path. Just to double check, I can do the same with the exact, but this time I attach the /abc at the end. And I end up at the demo2 again. Because /exact didn't match the exact term I had. If it was a path prefix, then it would have worked. So we can try this. So for example, if I have /routing/abc, then I can see I reach demo1 because the prefix of my path matched the rule. And with this, you can configure exactly how and where you want to redirect your requests. Or which backend you want to send it to. So the last example I want to show you today is the traffic splitting. So I again update my HTTPRoute. So everything on top here stays the same as before. But now I have two rules for the backend. So the first one is the demo app 1 with a weight of 20. And the second one is the demo app 2 with a weight of 80. This means I send 80% of my requests to the demo app 2 and 20% to the demo app 1. Then let's save this and apply it. And now it tests this. So I will just send a bunch of requests and we can see the response we are getting. To test this, I switched over to my WSL2 because I think with Linux it's easier than with PowerShell. So I just define my variable and then I send a for loop with the watch command and I send a new request every second. So here we can see we have the demo 1, demo 2, demo 1, demo 2, so it's switching a bit around, but now we have a lot of demo 2 requests and then we should see one demo 1 again. And over the time it will balance out to exactly 80 and 20% how we can send our requests. As I said, this can be very powerful for A/B testing and also for canary deployments to keep your blast radius small. And also it's very easy to update. So if we go back to our HTTPRoute, if something goes wrong now with my demo app 1, I can just update this HTTPRoute and have the weight here as 0. And then I can make here 100. And now I'm sending everything to the demo app 2. I only have to update like these two values and I don't have to redeploy anything or change any other configuration. So this makes it very easy and fast to switch over. This brings me to the end of my presentation today. So today we have seen that a Gateway API can be a great improvement over Ingress because it's modular. For me, it's easy to understand because I have my different objects and I know exactly what my objects do. But we also have seen that it's very easy to install it with a simple Helm chart. And with the deployment of different routes, we are able to control how we send requests to our applications. I hope it was useful for you. And if you're interested in more Kubernetes Gateway API Ingress, I have another session about the cert manager where I show you how we can create automatically TLS certificates. This will allow us to use HTTPS, and once it's set up, we don't have to touch it anymore. This means certificates will be updated automatically, and this will lower the amount of work we have, but it will also keep our cluster safe. If you have any questions, feel free to message me on LinkedIn. If you're interested in the slides or the demo, you can scan the QR code, and I hope to see you at my next session.